Today's topic is quadratic form to a canonical form using orthogonal transformation. So first problem, reduce a quadratic form to a diagonal canonical form. So how we have to write it? The quadratic form has been given in the question. We need to write it in a matrix format, the A matrices. Okay. Check in this x1 squared, x2 squared and x3 squared are the diagonal elements 3, 5 and 3. Okay. Remaining element how we have to write it means x1 and x2 is nothing but same as x2 and x1 are the same elements. Okay. So it is minus 2 half of the element. So a1 2 x1 and x2 I can write it a1 2 x2 and x1 is a1 2 1. So half of the element means minus 2 half element is minus 1. Okay. Same way x2 and x3 is same as x3 and x2. So it is a2 3 and a3 2 are half of the element. So minus 2 half element is minus 1. X3 and X1 half of the element, so it is 2 it's given, so half of the element is 1 for A13 and A31. That only it is placed in the A matrix. After writing a matrix, what you have to do means we have to write the characteristic equation and find the eigenvalue, eigenvector and modal matrix, normalized modal matrix and diagonalization. The procedures are same. So I have written here the characteristic equation A minus lambda equal to 0, determinant of this corresponding A matrices, and shortcut lambda cube minus S1 into lambda square plus S2 into lambda minus S3 equal to 0. So lambda cube, I am getting S1 to be 11, diagonal elements add, S1 is 11, S2 is nothing but minor diagonal elements, add everything, I am getting 36. S3 determinant of A, use in the calculator, I am getting 36. After getting a characteristic equation, use the calculator and find out your eigenvalues. 2, 3 and 6 I am getting. All the eigenvalues one by one, you find the eigenvector. I am directly writing the eigenvector because you know the procedure. For only one case, I am writing the eigenvector how to find. So, A minus lambda equal to into x equal to 0. So, in this lambda equal to 2, first eigenvector I am taking, lambda equal to 2 I am taking. So, substitute in this 2, I am getting the first equation and third equation are same. Only I am going to take first two equation. Do it by cross multiplication rule. Do the calculation by cross multiplication rule. So, commonly divided by 2. So, commonly divided by 2. So, first vector I am getting to be minus 1, 0, 1. Same way, lambda equal to 3 and lambda equal to 6, second vector and third vector we are getting. Okay, so all the three vector now what I have done, the first vector, second vector and third vector I am writing in a column wise, that is called as a modal matrix M. Okay. After writing a modal matrices, normalized modal matrices n is nothing but the numerator, only column wise. You have to consider the column wise. Okay. So minus 1 divided by in the column wise divided by root of minus 1 the whole squared plus 0 squared plus 1 squared. Okay. So it is nothing but root 2. So that only it is written here. Minus 1 divided by root of denominator term only this. Denominator term only this. Okay. So same way each element like that in the column wise. Okay. So when I write it, same thing you proceed for this column. 1 divided by root of 1 squared plus 1 squared plus 1 square root 3. So 1 divided by root of 1 squared minus 2 the whole square plus 1 square root 6. Okay. All the elements. This is called normalized modal matrix. N transpose you are able to write. Row into column you have to interchange and write it. Okay. So that is your N transpose. After that, what you have to do means now we are converting. So what is that means? N is orthogonal. Now whatever modal matrix we have calculated, no, we are using orthogonal transformation. So I am considering this N to be orthogonal means let X is nothing but X is the question given in the terms of X. Then some N into Y is the transformation. I am transforming to some variable that is called as Y. Okay. So that is called orthogonal transformation. This is the definition for orthogonal transformation. This already we have seen. So now this is our transformation. Okay. So Y is nothing but general Y is nothing but it is in a column wise Y1, Y2, Y3. Okay. If it is Y1 transpose is nothing but x1, sorry, same y only, but you have to write it in a row wise only. How you have to write it means y1, y2, y3. Because you remember this, how means it is a column vector. How I am saying means for a eigenvector calculation, what you did, remember that a minus lambda I into x equal to 0, where x is a column vector. X is nothing but x1, x2, x3. Correct? So it is 3 cross 3 means 3 element. Only 2 means 2. 4 means 4. It goes on. So the same only here also. It is y and y transpose. Now, so quadratic form, we know that quadratic form is nothing but, so quadratic form means q. Already we know that it is nothing but x transpose a, x is the quadratic form, general case. Okay, I already have given this when I start the quadratic form. So now it is nothing but y transpose into n transpose a n into y. Okay, this is nothing but d, diagonalization. D is nothing but diagonalization. Correct? D is nothing but diagonalization. Okay. So D separate I have to calculate. That D I can write in terms of Y, the equation. It is called as the quadratic form. Okay. So that only we need to write it. First I will tell how D separate we need to calculate. It's nothing but N transpose A N. Okay. This already everyone know. N transpose given, A is given in the question. N also we have calculated. Multiply all the three. Okay. So all the three matrices. Okay. All the three. Now I am not writing. I will write a general like this. A matrix. You have to replace it with the corresponding matrix. Okay. So you multiply it. When I multiply it, you will get one answer. When you multiply this both answer, that answer you can do it in a calculator. Okay, into n, again you multiply it. Okay, so you get the diagonal elements. Directly you can guess. Eigenvalues are your diagonal elements. 0, 3, 0, 0, 0, 6. Okay, you should get this answer. Okay, so D. D is nothing but eigenvalues 2, 3, 6 are the eigenvalues. Remaining every element it should be 0. D, I got this. Okay. This is called diagonalization. Correct? From a diagonalization, now quadratic, how we can write it means substitute this in this given equation. Okay. So Q is nothing but, when I substitute means how? Y transpose. Y transpose is nothing but Y1, Y2, Y3 into correspondingly 2, 0, 0, 0, 3, 0, 0, 0, 6 into Y1, Y2, Y3. So now you write it in equation format. It's nothing but 2y1 squared plus 3y2 squared plus 6y3 squared. This is called as the quadratic equation. Okay, we have converted now. One thing you have to check when it is orthogonal. So what we have to check it means, so orthogonal. So any orthogonal means we have three vectors. Correct? So what are all the three vectors? So x1 transpose into your x3. Okay. x2 transpose into x3. Okay. You cross check it. x1 transpose, what it is? x1 transpose is nothing but x1, I will write it here. First vector, I will write it. It is nothing but minus 1, 0, 1. One more time I am writing so that it will be easy for me. 1, 1, 1 I am getting. x3 I am getting to be 1, minus 2, 1. Okay. Correct? So x1 transpose is nothing but minus 1, 0, 1 into x3 element is nothing but 1, minus 2, 1. Okay. So now multiply it, minus 1, 0, 1. So it becomes 0. Correct? Same way x2 transpose you multiply it, x2 transpose is 1 1 into x3 you multiply it 1 minus 2 1. So when I multiply it, I am getting the answer 1 minus 2 plus 1. So it is 0. Okay. So orthogonal condition means any, okay, it may be some transpose into another variable equal to 0 if I get orthogonal condition. Okay. Suppose you can cross check this. Okay. After finding your eigenvector itself, you can cross check it. If you are not getting 0, your eigenvector is wrong. Like that, you can cross check it, then only proceed on. You will be getting the quadratic form correctly. Okay. So eigenvector, how to check the for orthogonal means this is the way you have to check it. X1 transpose into X3 and X2 transpose into X3. Both if you are getting 0, it's orthogonal condition satisfied. After finding your eigenvector itself, you cross check it, then you proceed on. You will get correct answer. Okay. So this is the way you have to check your orthogonal transformation. So completed. Thank you.